Hello, my name is Rincón Lopez, and I'm going to present the work entitled Calcium Silicophosphate 3D Printed Scaffolds for Trabecular Bone Repair, from SLURRY to Biological Performance. This work is focused on the development of 3D printed scaffolds for the regeneration of trabecular bone from bioceramics capable of inducing stimuli that promote tissue formation. As an introduction, additive manufacturing is a material layer-by-layer join process in which objects are manufactured from CAD design using an additive manufacturing technique as a 3D printing. In tissue regeneration, this is important because it generates the versatility to create complex structures using biomaterials that promote tissue formation, mimicking the biological and mechanical properties of bone. In this work is presented the strategy for 3D printing bioceramics scaffolds fabrication. First, formulations were developed to obtain bioceramics slurries from mixtures of hydroxyapatite and bioactive glass composites and binders using a high-energy milling process of the raw materials. The printing capacity of bioceramics slurries as continuous extrusion and thixotropy were evidenced through rheological characterization, exhibiting a suitable viscoelastic behavior for printing. A BioX extrusion printer was used to manufacture scaffolds from bioceramics slurries, and the defined 3D models were developed through CAD design. The printing parameters that allow the extrusion of bioceramics slurry were pressure, density, printing speed, and noise size to manufacture a scaffold with a rectilinear fill pattern. Scaffolds obtained from hydroxyapatite, silicocarnotite, and nagel-smithite phases with structural and morphological characteristics show the porosity, pore size, and compressive strength of trabecular bone. In vitro studies were carried out to determine the effect of the scaffolds of bioceramics phases on human umbilical endothelial cells and human osteoblast cells, evaluating viability, cell adherence, and the detection of protein associated with the vascularization and bone formation. Silicocarnotite and nagel-smithite scaffolds fabricated by 3D printed have better in vitro performance characteristics with human endothelial and osteoblastic cells compared to a scaffold fabricated with commercial hydroxyapatite. The products of the ionic release of scaffolds from the bioceramic phases showed closer values to the controls in both cell lines, concluding that neither the scaffolds nor their products induce cytotoxic effects. Through fluorescence microscopy, the hydroxyapatite, silicocarnotite, and nagel-smithite phases scaffolds are shown to be osteoconductive, in which the cells are seeded and cover almost the entire surface. According to the results, the nagel-smithite phase is the most osteoinductive and angiogenic phase, followed by the silicocarnotite. Both phases show the characteristics to be used as a scaffold for trabecular bone repair. Finally, authors thank to CONACYT for PhD scholarship and the project for the C-PRONACES 294 for the financial support. This work was carried out at Simvestab, CIDESI, and Universidad Autonoma de Nuevo León lab facilities. Thank you pretty much.